Hello, everybody. Thank you for joining. This is Tom Danvers here from Waygate Technologies again. So this is our third webinar on real 3D measurement. So this one in particular, number 3, is talking exclusively about measurement plane. So what is measurement plane? So again, as a reminder, similar aims and objectives to the previous sessions really that I've held. I'm intentionally trying to keep the same sort of format going. So measurements clearly extremely important for everyone performing RVI, remote visual inspections of certainly high value assets such as in the aviation industry for gas turbine engines. So it's very, very necessary to make sure that you've got extreme or very high confidence in all of the measurements and therefore all of the decisions that you're making whilst doing your inspections. So that's very much the aim of these sessions, and indeed this session that we're going to be talking to you about now. And specifically on this session, so measurement plane. So measurement plane, really, I'll be obviously talking a lot more about it and how it connects with existing measurement types that we've talked about in the previous sessions to enable you to unlock yet more information from your scene. There's a lot more we can talk about, but also I'll be mentioning the guidelines feature that we have on our Borescope. And we also have another feature called Edge View Angle, and I won't really have time to talk about that, but I'll probably make reference to it in this session, which gives you a visual indicator of the quality or the relationship between the probe and the target when you're performing these measurements and extracting the values from the measurements. So let's jump in. Again, a couple of slides here. Well, one slide associated with an overview of the measurement types, just for completeness. And for those that might be joining for the first time on this session, these are the types of measurements that we have on our Borescope today. The MViQ and the Everest Mentor Flex borescopes, in as much that we have real 3D measurement. Certainly for the Mentor Flex, it's 3D stereo, but not 3D phase. For the MViQ, we have all 4 types. Comparison being essentially pixel counting. Once you've assigned a reference to your target, hopefully in the same plane as your component that you're measuring, you're able to basically count pixels and perform measurements in accordance with those 5 types that you see under comparison. And then moving across to stereo, which is very similar to 3D stereo, using exactly the same stereo tip, you're able to do what we call traditional stereo, or just stereo associated with those measurement types that you see there, where by virtue of trigonometry, you're able to sort of align points on the target in relation to the, your probe situation in 3D space. But moving across the 3D measurement, where you have 3D stereo and 3D phase, you have a very much more measurement types available to you on the device. And for this session, which hopefully will be about 30 minutes, sometimes it's a little bit longer, we'll be specifically kind of paying special attention to these outlined in bold on this chart here, and really bringing home to the fact that we've got all of these different measurement types, but with the aid of measurement plane, we're able to unlock more from the scene. So what is measurement plane? Essentially, it is an ability on the Borescope to be able to assign a plane to a surface on the component that you've captured using either your stereo tip or your 3-dimensional 3D phase measurement tip, in order to be able to assign cursors to that reference plane. Why is that necessary? As I've kind of you see on the right hand side of this chart, so it enables you to place cursors where perhaps either there's insufficient data, so that's kind of traditionally highlighted as a red infill section or infill area on our Borescope UI user interface, or indeed if there's very poor quality data, you're able to apply a measurement plane. And a measurement plane is a plane of essentially 0 thickness, and it extends across the whole image. regardless of the scene. Once you've applied a measurement plane, all measurements applied either prior to or after to the assignment of the measurement plane essentially conform to that measurement plane. And how those measurement types conform to the measurement plane we'll be discussing here in this session. So what we have here is a point-to-line measurement. If I can press, yeah, there we go. So this is, I'll be going through these slides and then moving across to a practical demonstration on the Borescope, like you may have seen me do in previous sessions. So this is just a brief video, basically providing you with the sort of the information associated with aligning a point-to-line measurement to a measurement plane. Why is that relevant or applicable to, in this case, an edge breaking defect on a compressor blade? If I play this video again. So without the measurement plane, we have a distance of 1.5 millimeters. And what really can happen, not so much in this example, it's not exaggerated in this example, but if you're applying a length measurement, which is essentially a true axial measurement of an edge breaking defect, you can be measuring slightly longer than perhaps needs be, because there's a diagonal or a hypotenuse on a right angle triangle. Sorry to take you back to your school days, but if you can think of a right angle triangle, you've got a hypotenuse, which is the diagonal, and then you've got the opposite face, which is perpendicular from the base of the triangle. So if you're looking to provide a true sort of axial length of an edge breaking defect, then the use of measurement plane in conjunction with, in this case, the point-to-line measurement really helps that happen. So you can see the distance has kind of changed from whatever it was, but I can't remember what it was, to 1.61. And what you've heard me say many times before in previous sessions, always check your point cloud to make sure that not only is it, obviously it will be conforming to the measurement plane, but you have the ability to adjust your cursors and make sure that those cursors are correct. When a measurement plane is applied to an image, you're able to basically place your cursors anywhere on the screen. Whereas that wasn't the case before. If there was no data, then you wouldn't be able to generate a measurement. But when a measurement plane is applied, you can place your cursors anywhere. So it's very important to make sure that you've got those cursors placed correctly and appropriately. And that's so I'll be talking about guidelines when I move to the practical demo, but on this chart, you'll see on the right-hand side, these very sort of subtle sort of black lines. These are sort of guidelines, well, we call them guidelines. And paying special attention to guidelines really helps you get greater confidence in making sure, indeed, the two positions that generate the datum point or the datum line for the point-to-line measurement are assigned truly on the edge of the blade, rather than hovering over the end of the edge of the blade and projecting onto a surface in the blade in the background, for instance, and therefore generating a measurement that's too long. So you want to basically generate obviously the most appropriate measurement for that defect that you have. And the use of these guidelines and measurement plane really help you to do that in this case. So as I move through these slides, so I'm moving away from point to line, and this is an area measurement, as you can see, and you can pretty large area of missing material that you can see on here. So here I've applied an area measurement to this image, and you can see by me spinning the point cloud around that the plane of that area measurement is not does not conform to the plane of the blade. So here I've applied a measurement plane, and then you can see the area has adjusted because now the plane of that area measurement conforms to the measurement plane. I can't remember what the value was. So that's now 50.8 millimeters. And yeah, originally it was 60 millimeters. So it's dropped from 60 to 50 millimeters essentially, by making sure you can check by the point cloud that you can see here that's clearly off the surface or off the correct plane of the aerofoil, especially with that point that's dropped onto the abradable liner. That's necessary, and you realize that obviously by checking the point cloud, and then by applying the measurement plane, all of the points for this area measurement conform to that measurement plane. Again, you can check again like you see here in the point cloud. And so that area measurement has dropped from 60 to 50 millimeters. So that's very important to make sure that obviously you've got the right measurement for the defect that you have presented in front of you. Next measurement types. This is a depth measurement. So you're hopefully familiar with how depth measurements are generated by first applying 3 points that generates your reference plane, and the fourth point you drop onto the tip of the blade. This is kind of the unusual case when it comes to the measurement plane. When you're using measurement plane in conjunction with depth measurement, it's only the fourth cursor that conforms to the measurement plane, not all four, but only the fourth point. So you can see in this short video clip, I've generated a measurement plane on the face of the blade. And you can see the reference plane is on the abradable liner that's perpendicular to that reference plane. So if you have a noisy or poor quality or incomplete 3D phase measurement signal, then the use of the measurement plane allows you to place your cursor accurately on the edge of that blade. Rather than sort of placing it on a noisy surface, or indeed you're not able to apply it onto a surface that perhaps is missing any data. So if you've got a poor quality image, or it's very noisy for one reason or another, it could be very shiny material, or perhaps you can't get close enough, so the noise in the signal is significant, then applying a measurement plane in this instance to clean up the noise on that measurement plane, so that you can apply that fourth cursor to the position that you really need it to be in order to get a good quality, accurate depth measurement in this case. So just to reiterate, when it comes to depth measurement, it's the fourth point that conforms to the measurement plane, not the first three. So essentially what you've created by doing measurement plane with depth, you've got the interface of one plane against another plane, and what we've got is a length between that surface that's generated here, like just over 2 millimeters. Kind of an unusual one from a gas turbine point of view. This is a depth profile. So depth profile, you would have heard us me talk about in previous sessions, that essentially generates the profile or the depth of material, either extending below or above a reference plane. And the reference plane is set by the two cursors. So what we have here, I had to find this image. I didn't have many use cases that apply to this logic that I'm taking you through now. But if you're wanting to extrapolate or basically determine the projection of material below a reference plane, rather than just using depth, you could use depth profile with measurement plane. So what you see here, and again, I'll demonstrate it live on the Borescope so we can spend some more time talking about it. You can see me applying a measurement plane associated with a surface covered in green. So we've talked about the green mask before. So that's material surfaces that conform plus or minus 1% from the reference plane of 0 thickness. So we got a good agreement with, and so there's good agreement. There's lots of green surface that you see there, flooded by the green mask, and that's projecting across the whole image. And then you can see when I've gone to the split screen depth profile view on the right hand side, you can see the projection of material below that reference plane, that measurement plane. So what was, I think it was a fraction of that value. So let me just forward it. So that was without the measurement plane, that was determining a distance of 0.3 millimeters. And the true value is more like 1.5 millimeters once you've applied the measurement plane to that depth profile image. So again, it gives you a lot more appropriate information when you obviously use measurement plane in conjunction with these measurement types. I haven't got an example that I was going to take you through for area depth profile, but the same concept applies. If you've set up a surface and it's difficult for either side of the surface that you're wanting to generate a profile against, just like we have here, we have one surface and the other surface is not on the same plane. You can apply measurement plane to area depth profile in the same logic as you see here for depth profile. And the last one I was going to take you through was a relatively new measurement that we released on our Borescope about a year ago. So this is radius gauge. not strictly a measurement type. This is kind of like a go, no-go measurement type. So this provides you the ability to apply a circle of a given radius or of a given diameter to the component, to the image, to the real 3D measurement image. So what you see here is a bore blend of a compressor blade. So a really nice shaped scallop blend. And the use of radius gauge enables you to determine whether or not the shape of that bore blend, in other words, that curved surface, conforms to an acceptance limit for that type of bore blend. So this is new on our Borescope, so it kind of relatively new, about a year or 18 months ago it came out. And why I'm talking about this here is in order to generate the ability to determine the radius of that surface of the bore blend. There's three circles that you see on the image, but the larger image you'll appreciate without the use of a measurement plane. If I play the video clip again, you'll see that circle that is actually projected onto the blade in the background, which is clearly not what we want. So when I've applied the measurement plane, and I'll describe to you what the workflow is, I've kind of simplified it in this video clip here. Once I've applied the measurement plane, you can see actually, and I've applied the measurement plane to the blade in the foreground, all of the cursor points, all of those circles with the radius gauge conform to that measurement plane. So you can see it snap back up immediately onto where the bore blend is. So that wouldn't have been possible without the use of measurement plane. The other two smaller circles, they are projected onto the blade. So actually there was no requirement, or is no requirement, to use measurement plane when assigning those other two smaller circles to, again, to determine the appropriate sort of shape of that blend lead out sort of surfaces. So if those two were only needed, then you wouldn't need measurement plane. But that third circle that you see on the left-hand side, yes, in order to be able to make that shape happen and determine that value, then you do need to assign a measurement plane to that image. So let's do a quick time check. So I'm about 15 minutes in, so great. So I'll move across to my Borescope and take you through this in a little bit more detail. Let me just... excuse me a second. Just moving across to my Borescope. Okay. Share screen. Right, excellent. Finally got there. Sorry for the extra pause there. So this is my Borescope screen. So I've got essentially those 5 images that you saw earlier. But I wanted to take you through it a little bit more time. So you basically had the introduction. So if I load up the compressor blade, compressor blade nick. So this is quite a nasty looking nick. I've chosen this example because you can see here, I've already applied the cursors associated with the nick. So this is a curved, potentially deformed, but it is not, as you check on the point cloud, you can see the plane of the measurement, which is delineated by the blue square, is not aligned to the plane of the blade. Even though, as you can see on the left-hand side and on the right-hand side, the cursor positions are in a good position. So we've got a value of 5.39, but is that the true axial depth or length of that nick? It's not really a length, it's the depth of the nick. So if I apply a measurement plane, again, so I could apply the measurement plane before or after. So that's where measurement plane sits. It's amongst all of these other measurement types, but just to reiterate, measurement plane isn't a measurement type, it's a measurement aid. So by applying measurement plane, pressing the buttons, so uniquely the cursors for measurement plane are these triangle cursors, just to differentiate themselves from the measurement type cursors. So what we have is the green surface mass that you've heard me talk about in previous sessions. So it's important that your measurement plane is applied close to where you want to basically generate your measurement type. So if I've applied the measurement, so it was 5.13 millimeters with the measurement plane, and it's 5.39 without the measurement plane. So let's just apply it again. Add measurement, tap measurement plane. You just tap essentially 3 times, 1, 2, 3, and it's dropped down. So if I go to the right hand side, press the next measurement, you'll see now these guidelines, well, only slightly, but basically all the 3 points for the point align measurement are now sitting on top of this measurement plane rather than on the surface of the blade. And why that's appropriate is because we need to make sure we've got a true axial length measurement of this feature, this defect. I keep calling it length, it's kind of the depth of the nick. So using measurement plane is a fantastic way to make sure that you've got a really good, accurate measurement. And just to sort of reiterate, if I move the cursors out into space, I'm still able to do that because I've now applied a measurement plane to this surface. So you've got to be careful, making sure that once you're working with a measurement that has a measurement plane on it, that your cursor positionings are appropriate. And this is where you can work in the point cloud. And the use of guidelines are really important here. Less so on this blade because this is kind of a very thin sheet metal sort of surface. But we can talk about guidelines when we move to other measurement types. So that's how you would apply. So it doesn't matter whether you apply measurement plane before or after applying the point align. But for completeness, I preloaded this image with the point align already applied to the image, so you can tell the difference in the measurement type straight away. Okay, let's come away from that. Go to the next. Oh, I need to go live. Go to this image here. There we go. So clearly a large amount of missing material from this edge of a compressor blade. You can tell I've applied a measurement plane already. You can see these cursors. I've just entered the measurement state, as you can see on the status bar. So it's a recalled image. I'm in the measurement state, and I have active at the moment the measurement plane. So I've applied it around the area where I want to, in this case, perform an area measurement. So by going in and tapping on area, and I kind of like working in a full image. So I'm going to roughly apply the cursors. So it's not going to be pixel perfect, but for demonstration purposes, I'm going to just apply a measurement to determine the amount of material missing from this corner of the compressor blade. So essentially I've applied cursors to essentially the surface of the blade. Certainly I would have done if there was no measurement plane, but because there is a measurement plane, you'll appreciate, like I said before, all of these now are actually conforming to the measurement plane. So now I'm going to take another shot here, another point here, which is roughly the corner of the blade. And rather than just sort of press and attempt to get it close to there, I can just press done, and it will snap back to where it needs to be. Right, okay. And now I can minimize those buttons. I don't really need to. Let's get that up here. I pressed enter when I shouldn't have done, so I've got that point up here. So by pressing this surface, this corner point here, and by paying attention to the the dashed lines, I'm looking at the projection of the leading edge. So by moving my cursor left and right, adjust the projection so it aligns. And now I'm looking along the tip of the blade, so I just want to adjust that point there. And now I'm going to adjust up and down so my projection across the tip, as well as my projection across the leading edge of the blade, conforms. And you can see straight away, because this is obviously an area measurement, I've got an area value of 50 millimeters here. And if I now switch back to, let's say, my point cloud view and rotate, because clearly I've got a measurement plane already applied, we know all of those cursors that I've just attached to this image will conform to that plane. And you can see the guidelines here. So the guidelines are essentially those projections that project 90, they're perpendicular, they're 90 degrees projected either above or below the measurement plane onto the surface, either in front of or behind the component. So without the measurement plane applied, this point in the corner of the missing material would actually be applied further back in the background on the abradable liner, which clearly it wouldn't generate the appropriate area measurement that you're looking to achieve. So again, the use of measurement plane, understanding, making sure that you're working well in the point cloud view. So I'm in the full point cloud view, or indeed in the split point cloud view. You can interact and edit points either in the right-hand side on the point cloud view, or if you prefer to be working on the two-dimensional image on the left-hand side, you can change points there. It's really great to be able to use, and if you want to, you can do very fine adjustments by tapping the sort of the measurement, not the measurement zoom, the digital zoom window that you see in the center on this screen. So those, I think from memory, that's like 1/4 of a pixel every time you tap one of these arrow points. So it's a very, very small value if you really wanted to get fine positioning of each of these cursor points to get a really good quality measurement out from there. So the use of measurement plane in terms of in conjunction with area enables you to basically, in this case, measure an area of missing material. Okay, let's cancel that. Keep doing that now. Depth measurement. So this one's already saved with the measurement plane applied. You can see the 3 cursors there. So if I enter the measurement state, I'm going to spin my point cloud. So it's quite a noisy image, you can see, but let's just move the cursor point up and down. So while I wouldn't normally be able to do this, but I can, because I know I've got a measurement plane. So it's very important that you apply the positioning appropriately, because you want to obviously generate an accurate measurement type. If I deleted my measurement plane and repeated what I just did, let's move that across over there. There's, in this case, a very small amount of material or a surface that doesn't have any 3-dimensional information, hence the red flood. And then as I move the point closer to the reference plane, I'm actually applying my cursor, my 4th point is actually already on the abradable liner. So the depth value is actually negligible until it snaps onto the edge of the blade, where you see it jump from essentially less than 0.5 millimeter to 1.5 millimeters, 1.3 millimeters. Let's go to page 1, add measurement, go to measurement plane. Again, make sure that you're applying your measurement plane close to where you're, so if I apply it way over to one side, because we know this is a curved surface, this is obviously an aerofoil, a compressor blade. If I'm not cognizant of what I'm doing in terms of the measurement plane, is applying a measurement plane away from your depth measurement. So that will affect your measurement significantly. As I've done here, I've moved it way over to one side. So what it's now, it's like 2.8 millimeters. So if I bring those cursors much closer to where I really truly want to be applying a measurement, it changes the value significantly since it's a curved surface. So be very careful of where you're placing your measurement plane, not just in terms of making sure there's good agreement with the green surface mass, but making sure the positioning and the locality of those 3 cursor points for the measurement plane are close to where you're wanting to assign your measurement against. So we've talked about point to line, area, and then depth. So this is the slightly more unusual one. I don't use this a great deal myself when it comes to sort of gas turbine inspection, but nonetheless very applicable when you're using area depth profile, or indeed depth profile, as you see here. So this is an old image. You can see from the date it's like over 10 years old, but a really fantastic image that shows basically the change in the profile of material from the bottom of the image to the top of the image. And as you can see by scanning the point cloud, you've basically got depth profile being used inappropriately, because you're not able, if I go to this view here, you might be able to appreciate the distance that's projected between those 2 points clearly doesn't align. So if I go and apply a measuring plane, to that surface there, and if I snap back to, I didn't need to do that. Let's go back to the next measurement and then change my view. Let's just pick the largest view, and then go to options. Oh, I need to do that. Let's just that view there. So that's measuring the highest point above my reference plane. So if I go to below plane, there we go. That's what I wanted to try and do. So we've got the measurement plane assigned to the left-hand side in terms of the profiles you can see on the right-hand side of the image. Measurement plane is obviously on the bottom of the image on the left-hand side. And so that is now the new measurement reference plane and the measurement plane. And so the value of 1.5 millimeters, as you can see on the right-hand side, basically allows you to understand that the drop in surface, or the depth of material from that measurement plane, is that value that you see there. So a very powerful way to use depth profile, even though you don't have the surface conforming every time you apply your 2 cursors. You'd have seen me in a previous session apply depth profile or area depth profile either side of a weld bead, for instance, along a tube surface. And outside of those weld surfaces, you'll have conforming material. So there's no requirement to apply a measurement plane. But here we don't. It's obviously not a weld bead surface. So this is a surface that contains intergranular corrosion, as you can see on the label. But you're still able to generate that projection below, or indeed above that plane, by using measurement plane. Now the next one. Let's go back in. So I wanted to sort of spend a bit of time talking also about radius gauge. So again, a new measurement that came out not so long ago. This is the saved image. So if I just recalled it, now enter the measurement state, as you can see. And I've saved this image without the measurement plane applied. Now this applies to, we know there's a requirement for when you're bore blending LEAP engines, whether it's 1A or 1Bs, that not only is the depth and the width of the blend must conform to an appropriate relationship to the defect that you're blending, but also the shape. So in order to conform to that acceptance standard, we generated the ability to understand the shape in terms of the radius. So what we have here, I've deleted, no, I haven't deleted, the point to line is still there. So you have a value of 1.22 millimeters, which is the depth of this, not the depth of the defect, but that's the depth of the bore blend. And as you can see in the text label, the acceptance criteria in this particular bore blend sort of procedure is the radius of the scallop blend, in this case, needs to be at least 5 times the depth of the blend depth. So at least 5 times 1.22 millimeters. So I've applied essentially circles that conform to 5 times 1.22, but also 2 times 122. So what I'm going to do, and I'm just going to, I'll draw those radius gauges again shortly, but just for the time being, I'm going to apply a measurement plane. Actually, I'll just show you the, let's go to full image. So before I apply the measurement plane, you'll see the blade that I want to interrogate is on the right-hand side here. But before I apply the measurement plane, you'll see there's a circle that's projecting onto the blade in the background, which is not what we need at all, not what we want. So I'm going to add a measurement plane just to demonstrate how. Press enter. Again, just three points shown by the make this measurement, and then you can see all those circles. So that's it's going to present all three circles separately, but you can see everything snap. If I go to the full image, you'll see everything in its entirety. So everything snaps to the measurement plane. So here's an example where we've got, I don't really need to go into the detail in this particular case, but we've got a circle of a given diameter and a blend that conforms to that diameter or that shape. I think let's just go and delete that circle, and then I can just demonstrate to you how that is generated. So if I go to full image, just as well clarify, I can delete that. Oops. No? Delete. Okay. Press done. Okay, add measurement. In this case, I've already got obviously two circles, two radius gauges applied, plus my measurement plane. So I'm going to add my third one, radius gauge. So just to remind you, the workflow here is essentially, I've got a point-to-line measurement that you can actually see in the soft key below that says 1.21 millimeters. So I don't have to type in 1.21 millimeters. I just press the button. I then press multiply. In this case, 5. And you can see the answer in the keypad that says 605. 6.05 millimeters. Now, if I press save radius, it's going to generate a circle of 6.5 millimeters, 6.05 millimeters radius. If I press save diameter, the circle projected onto the screen will be 6 millimeters in diameter. So I'm going to say save radius. So there's my circle of the diameter that I want generated onto my three-dimensional real 3D image. I'm now going to basically draw it and move it across to where I want it to be, and I'm basically being able to provide that go, no-go quality assessment of the shape of the Boreblend here. So without measurement plane, I wouldn't be able to apply that point onto against this Boreblend surface. So again, radius gauge with measurement plane is a way of being able to, in this case, this use case is to be able to determine the shape of Boreblend that conforms to an acceptance criteria. So that's the end of my practical demo. I've gone over time. I like going over time, it seems. Let me just move to my summary page. Stop screen. Okay. So we've gone through all of those measurement types: point to line, area, depth, both depth profile and area depth profile you heard me talking about, plus radius gauge. So applying measurement plane really extracts more out of those measurement types. If you weren't able to use measurement plane, there's certain things that you wouldn't be able to do, even though you had point to line and area and all the other types that we talked about. Probably didn't explicitly say this earlier, but there's only one measurement plane that can be applied per image. Regardless of when you apply measurement plane, it conforms. Everything subsequent or prior to applying measurement plane conforms to that measurement plane. And the only one that is slightly different, should we say, is the fourth point for depth measurements. That's the fourth point that conforms to the measurement plane, not the first three. But when it comes to point to lines, when it comes to areas, radius gauges, indeed depth profile, you basically, the measurement plane enables all points, cursors assigned to that image conform to the measurement plane. I keep stressing this, make sure that you're using making special note to, if it's deactivated in your settings, it shouldn't be, you can deactivate it, but always make use of the green surface masks. That enables you, because if you're applying a measurement plane, you can still, there is still the ability to apply and generate a measurement that isn't appropriate. So use the green surface mask to make sure the measurement plane you're generating is close to the surface, and you're creating a nice clean plane upon which you're going to generate a measurement from. So those guidelines that you heard me talk about briefly, I didn't go into much detail about them. They're great visual aid to make sure that your cursors are being assigned appropriately to the edges of blades, essentially, when you're measuring perhaps the depths of nicks. So the guidelines are very useful visual aids to make sure you've got the really good positioning. And lastly, I keep mentioning this, the measurement guide, measurement handbook. Very useful document. It gets updated regularly as and when we create new measurement types on our borescopes. So we've got a fantastic comprehensive guide to all the measurement types. It goes into much more detail than what I've been able to do in these webinars. But yeah, a lot more information can be shown on there. It's on our website. Just type in that link, you'll be able to download it. Yeah, it's all available. And briefly, yeah, I mentioned this before, the Mentor Flex that we have out, which is obviously a slightly different product to what this MViQ is. For those devices that are already enabled with traditional stereo, there is like a very attractive discount offer that's running at the moment, so that you can upgrade to 3D stereo and extract all of the value that you've heard me talk about in these webinars, because it applies to 3D stereo as well as 3D phase measurement. There's a very attractive sort of promotion that enables you to get a lot of money off the upgrade for the Mentor Flex to get it upgraded to 3D stereo, because we exploited the ability to do 3D stereo on the Mentor Flex earlier this year with the software update. So if you're interested in real 3D measurement and you're operating a Mentor Flex, but don't yet have 3D stereo enabled, then please do get in touch with your local sales rep, and we'll make that happen. So that's all from me. Sorry again for going over time. It's a tradition. I should, but yeah, hopefully you found that useful. And yes, I'll see you shortly in the next sessions. Thank you. Goodbye.